Okay, so equation of a circle. This is part 6, and it's right here. I'm going straight to the chase. X minus h squared plus y minus k squared equals r squared. A couple details I want to point out. Notice that it is being added, so both of these terms are positive on the outside. When you start to change the signs, both negative, positive, and negative, you get different shapes. Also notice that they are both going to have ones in front. If you change the numbers in front, whether it becomes a fraction or whether or not the numbers change, you start to get other shapes as well. So for example, if this one had a 1 in front of x and this one had a 3 in front of y, you would start to get an ellipse because it would stretch in one direction. But as long as it's the same, we do have this circle shape. H, K, and R, really simple. H and K represent the center of your circle, R represents your radius. And there's something really satisfying about this formula, because think about what our definition of a circle was. All points equidistant from a given point called the center. So by definition, I needed two details. I needed to know the center, and I needed to know how far away all the points were from the center, aka the radius. Well, guess what? Those are still the only two details you need. If you can tell me the center, HK, and you can tell me the radius, R, you can write the equation of your circle. And there's something really satisfying about that, at least to me. So, what I want to key in on though, is these guys right here. Notice that my default equation has subtraction inside. This also happens to follow the same pattern we had when we did parabolas a couple chapters ago. If my value was inside the function, inside the square, it did the opposite of what we expected. Minus the number meant I moved to the right. Plus the number meant I moved to the left. So for example, suppose I want the equation for a circle with center 5, negative 10, and a radius of 8. Okay? If I take those values, H, K, and R, and plug them in, I would get the following. X minus 5, that's H, plus Y minus a negative 10. Let me zoom out a little bit. Okay. Minus a negative 10 makes that plus 10. And then r squared gives me 8 squared. So what does that mean? If I were to graph this point for the center is telling me to go 5 units to the right and 10 units down. But if I look at my equation, it has a minus 5. So minus 5 means I'm going to the right. Now the plus 10 in here means I'm going down. The signs change because they're inside. The only other detail I'm going to mention at this point, I've got the 8 squared. It is acceptable to multiply that out. So you might see this same equation written as the following. Y plus 10 squared is equal to 64. Some places prefer one over the other. I'm not picky because it's a very minor detail to write it one way or the other. There's an appeal to the first case in the sense that, hey, the radius is staring at you. There's appeal in the second case in the sense that, hey, there's nothing to multiply out. There's pros and cons to both. I personally am not picky, but I want you to be comfortable with both. Suppose you get a multiple choice test. If you write 8 squared, you better know it's 64. Or suppose they give you this is the equation of a circle and you need to do some math with it, you need to understand that if you actually want the radius, you need to take the square root first. So you need to be comfortable seeing it both ways and how to correctly interpret it. If you see the structure of a number squared, you're staring at the radius. If you don't see that structure, you need to take the square root in order to get the radius.